In this part of the lesson, we're going to look at side angle side congruence. So let's say we take triangles from two sides and an included angle. Your sides could be 6 and 12, and they meet at a 52-degree angle. Now, an included angle means it's the angle between the two sides that are given. So see how I said they meet at a 52 angle? Where the two sides meet, that is the included angle. So here we have, I've got side 6 and side 12, and they meet. There's my 52 degrees. And how many different ways can I make a triangle? Well, I haven't specified the length, so I can put this anywhere I want. But you can see that I can only reach right there. So I'm really only able to make a triangle that has 52 degrees, 30 degrees, and 99 degrees. So there's only one way to make a triangle when I give you side, angle, side. So the side, angle, side postulate says it basically two different people are given two matching sides and the angle between them, the included angle, has to be the same. Then the two triangles have to be congruent. So we'll look like side, angle, side. These are congruent, means that the triangles are congruent. And the postulate, again, is if two sides in the included angle of one triangle are congruent to the corresponding sides and angle, then the triangles are congruent. In this example, I'm trying to determine which two angles are congruent by side, angle, side. Now, I already have the markings here. AD is parallel to BC, and also AD is congruent to BC. So the question is, what is my congruent statement? Which two triangles can I say are congruent? Well, it might be tempted to say EAD and DBC, but let's see what we know. First of all, I've got parallel lines and a transversal. So automatically, I know these two angles right here are congruent. Then I have this side BD. Well, it's actually congruent to itself by the reflexive property of congruence. So now you can see I have A, one mark there, to D, across two marks to B, right? And I can do the same thing. A, D, B, C goes across one mark to the angle, then back across the two marks. So the way I know I have them matched up is make sure when you trace your triangle that you're going through the congruence marks in the same order. So I can say that triangle ABB is congruent to triangle CBD by side, angle, side postulate. There are some helpful theorems and postulates. We already talked about the side theorems and postulates. Now I'm going to focus on the angles. So if I have two vertical angles created by two intersecting lines or segments, then I know the angles that are across from each other, the vertical angles, are congruent, and that's the vertical angle theorem. If I have an angle bisector, then I am cutting an angle in half and creating two congruent angles. And the same thing with a perpendicular bisector, it just creates 90-degree angles. Now in this proof, I have these overlapping triangles. So these are a little trickier when I have triangles on top of each other. First of all, I know that RS is congruent to UT. That's part of the given. Now, I can see there's several triangles here, but I'm trying to do RST and UTS. That's what I'm trying to prove. So let me first go ahead and put those triangles separately. There's triangle UTS, and there's triangle RST. And I'm going to go ahead and move these congruence marks, not really move them, but copy them over to my new triangles. Okay, so now I have my separated triangles. This will be a little easier. Don't lose that original drawing. It's still going to be helpful. Now I can say the two angles are congruent by definition of right angles. And honestly, I probably should have switched step 4 and 3 on here, but that's fine. Then I have ST is congruent to ST. Why can I say that? Well, it's the reflexive property of congruence. Basically, a side is congruent to itself. And then finally, I have these two angles are congruent by the definition of right angles. Well, now you can see I have a side, an angle, and a side. A side, an angle, and a side. And it's UTS and RST. So that's using the side angle side congruence postulate. So for further reflection, what is an included angle? It is the angle where the two sides meet. What are some different ways to show that angles are congruent? Well, you have vertical angle theorem, angle bisector, perpendicular bisector. A lot of those will help you find congruent angle pairs. What are some strategies for overlap triangles? Redraw them separated. Make sure you put any congruent marks that are in there, that you transfer them to your new drawing. And then finally, how are special segments helpful in triangle congruence proofs? So for your individual practice, sometimes you might have a median that creates a midpoint. So that would help you find two congruent segments. If you had an angle bisector, that creates congruent angles. A perpendicular bisector creates congruent angles and congruent segments. So it might give you either one.